So across this RL here, you have to find the voltage. So to find the voltage across the RL, you can use any theorem. So here I am going to use the Norton's theorem to find the voltage across RL. But by using the Norton theorem, first I will find the value of the current passing through RL, and then by using the Ohm's law, I will find the value of the voltage across RL. Now the steps for the Norton's theorem is, in the step number 1, you have to remove the RL. So here there is a RL. This is the position of the RL. So this is the RL here. So first you have to remove this RL. Okay, now, so first you have to remove this RL, and then after you have to short it. So by a wire, you are shorting this. Okay, this in the circuit, the point is given A and B, and the load is connected between the point A and B. So now this is shorted here, and in this shorted wire you have to find the Newton current. Now look at this, the shorted wire. So parallel to this shorted wire, like this, there is a one resistor here. This is 3 kilo ohm resistor, and this 3 kilo ohm resistor is shorted like this. So this wire is coming here, this shorted wire is coming here. So when the current is coming, see, when the current is coming here, so the whole current will come here. So there is no current. So here the value of the current is 0. No current will pass through this 3 kilo ohm resistor. So all the current, it will pass through the shorted line from the wire. So it means when the current will come here, when the current will come here, and the current will come here, and the current will come here, so the resistance of this wire is, it is 0. So the maximum current, it will pass from here, and no current will pass from here. So when no current is passing from this point to this point, so there is no meaning of this resistance. So what we can do, we can delete this portion. So we can delete this portion, and here also we can delete this portion, and here the wire, the position of the wire, the position of the wire will be like this. So here the wire will come here. This is the wire, and there is no meaning of this 3 kilo ohm resistor, and the wire is coming here, and this IN you have to find. Now basically the IN is, because this 1.5 kilo ohm, this 1.5 kilo ohm, and this wire, they are in series. So what the current coming here in 1.5 kilo ohm, the same current is passing through this wire. So this IN is equal to the current which is passing through 1 kilo ohm. So now this you have to find. Now this one, the current we have to find from this 1.5 kilo ohm resistor. Now we have the two loops, and we have two sources. The one is the voltage source, and the another is the current source. So here my planning is to use the KVL between these two meshes. But the problem here with this current source, this is the problem here. We cannot use the, we can use the KVL, but there is a special method to use the KVL. Now here if I take this loop, so in this loop the current is passing I1, and in this loop the current is passing I2. So the problem here is, when I will use the KVL in the mesh number 1, so I have to find what is the voltage it will come across this current source. So here it is a difficult part. And when I will use this I2, so again I have to find how much current is coming here across this current source. So here this is if this is the voltage source, there is no problem, because in the KVL, if there is a voltage source, it is easy to find. But if the current source is coming, it is little difficult to find. So now actually here I am going to use the super mesh. So this super mesh, what is this super mesh? Here if I delete like this. Now, so now here this current here in this branch, so this is, see, this is if I say this is B, this is A, or this is B, and this point is C here. So in this B and C, the current is coming like this. So the current is coming I1 from here, and from here, from the loop 2, from the mesh 2, the current is going like this, and they are opposite in the direction. And they are opposite in the direction. So here in the branch, BC, there are three currents. So I will make the one current equation separate. If you have the current source and you want to use the KVL, so make one equation by taking the current source. Okay, now if you see this, if you see this current source, this is the current source, and the direction of the current is going like this, and this going like this, and here, and the value of this is 12 milliampere. And from here the current is coming I1, and from here the current is going I2. So here three currents are coming, I1, I2, and this current source, this is 12 milliampere. And here this I1 and this I2, they are opposite. So this I1 and this I2, they are in opposite direction. They are moving in opposite direction. So what to do? You minus this one. Okay, so this I1 is coming from the voltage source. So I will take this first, I1. So here I will give the sign to each resistor by taking this voltage source. So this is plus here, and this is minus here. So this is plus, and this is minus. So this is plus, and this is minus here. So according to this, I am giving the sign to the resistors, and the current I will take according to this voltage source. So here it will come, this will come I1 minus this I2, and this is equal to 12 milliampere. So this equation we need before using the KVL. So by using the current source, so whenever the current source is coming, you use like this. So here I say this is equation number 1. Now this is a mesh, but this kind of mesh is known as the super mesh. So the name of the mesh is a super mesh. Now what is the difference between this super mesh and the normal mesh? We use super mesh when there is a current source between the two meshes. So before it was here like this. So before it was at this place, there was a current source like this. So here this is one current source, and this is one mesh, and this is one mesh, and this is also one mesh. So this is mesh number 1, and this is mesh number 2. So between these two meshes, this current source is a common current source. So when I am taking this mesh 1, so this current source is coming. When I am taking this mesh 2, so again this current source is coming. So this current source is common to both the meshes, the mesh 1 and the mesh 2. So and this we cannot solve the problem by taking the current source. So what we do? We take the super mesh. So how to take the super mesh? We have to delete this. We have to delete this current source. Now I have deleted this current source. Now this mesh becomes a super mesh. Now this is not a mesh. Now this is a super mesh. Now in this super mesh, the current what we have taken in this 1.5 kilo ohm, this one. So from here the current is going when we have taken the mesh. I am taking with respect to the mesh 1. So with respect to the mesh 1, so here the current from here, it is going I1, and the current in this, and the current in this 1.5 ohm, it is going, this is going I2 according to the mesh 1 and the mesh 2. Now what you do, this is a super mesh. Now in this is the super mesh. So this is the super mesh. Now apply the, now in the super mesh, no need to give the current like this I3, and no need to give like the current I1, I2 and I3. So here only we have to take the direction. So the direction is a clockwise direction, and this is minus and this is plus. This is minus and this is plus. So now apply the KVL rule. So this is KVL rule to the super mesh. The KVL rule to the super mesh. The KVL rule to the super mesh. Now start from the voltage source. So the voltage source is 0.5. So and it is minus 2 plus like this. So it is 0.5 volt, and then this is 1.5 kilo, this one. So this is 1.5 kilo ohm, and this is plus 2 minus. So plus 2 minus means it is minus, and this is 1.5 kilo ohm. So here I am taking ohm. So here I am taking ohm. So in ohm the value will be 1500. So this is 1500, and the current is passing, this is I1. So the current is passing I1, and then again this is minus 1500, the another, this one. So from here, so the current is passing, this is I2, and this is equal to 0. And this will be if I solve this, okay, then if I solve the equation, the value of it will come like this. So this is I1 plus I2, and this is equal to, so here this, after solving this equation, it will come I1 plus I2, and this is 0.33, and I am writing in milliampere. So this is milliampere. So here I am taking this equation number 2, and before I have taken the equation number 1, and the equation number 1, what the equation number 1 we have solved on the last page. This is I1 minus I2, and this is equal to 12 milliampere. So this is equation number 1. So now you solve the equation 1 and the equation 2. Just what you have to do, just to add the equation 1 and the equation 2. So after solving this equation 1 and the equation 2, you will get the value of the I1. The value of the I1 is, it is 6.15, it is milliampere. And the value of the I2, okay, solving these equations, the value of the I2 is, this is 5.83 milliampere. So I got the value of the I1 and the I2. So here what is I2? So this I2, the current which is passing from here, this is the I2, and this I2 is equal to IN. So here I am holding the value of the IN. So this IN is, the Norton current is 5.83, and this is milliampere. So this we have to use. Now here we have to find the RN. So this Rn we have to find. So to find the value of the Rn, first we have to remove this Rn. So RL we have removed, and the voltage source should be shorted, and the current source should be open. So here this is the position of the current source. It is down, coming down, the current is coming down. So this is the current source here, and the current source is 12 milliampere, and here there is a voltage source, and the voltage source is 500 milliampere. So this is 500 milliampere. So what you have to do in this circuit, first you have to remove the RL. So RL is removed between the point A and B, and after that you have to delete this, you have to short this. So shorting from here to here, so this is shorted now. So this, the voltage source you have to short, and the current source you have to open means you have to remove this. So this part you have to remove from here. So this is open now. So this is open from here. So between these 2 points there was a current source. So this current source is open from here. It is open. Now the open circuit has no meaning. So what we can do, we can delete this. So it has this side has no any meaning, and this the shorted one. So the shorted one means there is no role of the battery. So it means there is no battery. The battery is not there. It is like a simple wire. So if I delete according to this, so this is shorted. So here these things are not there. So it means this circuit is connected like this. Now after shorting, the voltage source and opening the current source, so this is like this now. So in this, now this circuit is very simple. Now these two resistors are in series. So these two resistors are in series. So these two resistors are in series, and they are with the parallel with the 3K. So this 1.5 kilo plus this is 1.5 kilo, they are in series, and after that they are parallel with the 3K. So it will come like this. So and this is equal to Rn. So after the calculation, the value of the Rn, it will come, the value of the Rn, it will come 1.5 kilo ohm. So this, the value of the Rn, it will come 1.5 kilo ohm. So this is the value of the Rn. Now we will move to the step number 3. Now in the step number 3, you have to draw the Norton's equivalent circuit. So this, you have to draw the Norton's equivalent circuit. This Norton's equivalent circuit you have to draw. So Norton says, whatever the current source or the current you got, so you draw the current source like this. So draw the current source like this, and here the value of this is the current source, and the value of the IN, we got the value of the IN, the value of the I2, we got 5.83. So this is 5.83 milliampere. So here this is 5.83 and this is milliamp. Now with this current source, you have to draw the Norton resistance, which is parallel to this voltage source. So here it will come. So here it will come. This will come the resistance. This will come the resistance, and this is Rn, and the value of the Rn is, this is 1.5 kilo ohm. So this is the Norton's equivalent circuit, and with this parallel combination, you have to draw the RL with this parallel combination. So here this RL will come here, and the value of the RL is, this is 2 kilo ohm. Now what you have to do, now find, you use the CDR rule. I can rub this. Okay, so no need for this one. So first you have to find the, you cannot find the voltage directly here. So what you do, by using the CDR, by using the CDR, you find the current. You find the current through RL. So here it will come, this will come RT. So this RT, so this RT is the sum of, so this RT is the sum, this is the parallel sum. So this RT is the sum of Rn, and this is parallel to Rn, and this is RL. So this is equal to like this, and here it will come, this will come RL, and this is multiplied by the source current. Source current means This is the source current means the Newton current. So this after the calculation, this RT, it will come 857 ohm approximately, little more. And this is the RL is 2000 ohm, and this is the IS. The IS is this, the IN, the current which is coming here. So this is the IS. This IS is 5.83 milliampere. So here multiply by 5.83 milliamp. So after the calculation, your answer will come in milliamp only. So in milliamp, it will come 2.4 milliampere. So this is the current which is passing through RL. Now you have to find the voltage across RL. So this is easy now. You can find the voltage across RL. So what to do? So this is the voltage across RL. So here this is I multiplied by RL. So this is 5.83 in milliampere, and this is multiplied by 2 kilo ohm. And after multiplying this one, you can find the answer. So this is approximately 11 point something it will come. This is approximately 11.6 volt. Yeah, so this circuit diagram is from the multisim. And in the last page, I have taken the voltage across the VRL. So here this is IRL, and this is multiplied by RL. So by mistake I have taken 5.83. At the place of IRL I have taken IN. So that is wrong here. So this is IRL. The current which is passing through load, that is 2.4 milliamp, and the value of the RL is 2 kilo ohm. So by this way it will come 4.8 volt. So this is the voltage across RL. This is 4.8 volt. So this is the theoretical answer. So this is coming according to the calculation. This is coming according to the calculation. And here the answer, the voltage across RL is coming 5 volt. So there is a difference. So there is a difference of 0.2 volt between the manual calculation and the simulation calculation. So also we can find how much current is passing from here. So this here the current which is, because by using the Norton you cannot find the voltage, you can find the current only. So my calculated current here, if you see the current passing through IRL, the current passing through the load resistor is 2.4 milliampere, and here it is coming, this is coming 2.5 milliampere. So there is a very small difference between the simulation and the calculated result.